Hey Pre-Cal, I am taking a break from my Criminal Minds marathon to do another video. So for the past 2 days, you guys were working on addition and subtraction formulas for sine, cosine, and tangent. And today we are going to start 7.3. We're going to do the first part, and we are learning double angle formulas. Again, we're going to learn double angle formulas for sine, cosine, and tangent. So double angle just means instead of sine of x, you have 2x. Same thing for cosine, same thing for tangent. So sine of 2x is equal to 2 times sine x times cosine x. Cosine of 2x has 3 double angle formulas. And in a minute, I'm going to show you how you can derive the other 2 by simply knowing the first one. So if you can remember, the first one is cosine squared x minus sine squared x. Then the way that we come up with the other ones, let's go back to the Pythagorean identity here that we know and have used a lot, right? Sine x squared plus cosine x squared equals 1. So what if you got cosine squared x by itself by subtracting the sine squared x over? Then I could replace cosine squared x. So I would have 1 minus sine squared x. And then I would keep the minus sine squared x. And that's how we would end up with the second one, because then you would combine like terms. Or what if we go back to sine x squared plus cosine x squared equals 1, and this time instead we solve for sine x squared by subtracting the cosine x squared over. And again, going back to this first one, I would have cosine squared x minus, now in parentheses, I'm going to plug in what I know about sine squared x, which is 1 minus cosine squared x. And then I would have to distribute the minus sign, and that's where that second one comes from. So really, if you can just learn that first one, you can get to the other 2 as needed. And then tangent of 2x is going to equal 2 tangent x over 1 minus tangent squared x. Unfortunately, I don't have any cool mnemonic devices for you guys to use for these. You just have to learn them. That's really all I can say. What I am going to do is prove how they came about. So I'm going to start by talking about sine of 2x. Now, how do you get a 2x? That's easy. You add a 1x and a 1x together. And then we can use the formula that we've been working on the last couple of days. This is the sine addition formula. That's the one that South Carolina is a cool state. So I would have South Carolina is a cool state. And then these 2 things are the same, aren't they? Sine x, cosine x. This is also a sine x, cosine x. So I could combine like terms, and I get 2 sine x, cosine x. And that's where the double angle formula for sine comes in. Let's try to do the same thing for cosine of 2x. So I'm going to turn the 2x into x plus x. So we're going to use the addition formula for cosine, and that's the Charleston County Schools stink. So Charleston County Schools stink, and cosine x times cosine x is cosine squared x, and sine x times sine x is sine squared x, and there you have it. So really, just memorize, obviously, the sine of 2x, memorize the first one for cosine of 2x, and then know the tangent one as well. So let's jump in to some examples. So this first example says that cosine x is negative 2/3, and x, so the angle x is in quadrant 2, and we're being asked to find cosine of 2x, sine of 2x, and tangent of 2x. So the first thing that I like to do is get a picture going. So I'm going to be drawing a right triangle, because you know you're using these for right triangles. We're going to be in quadrant 2. So here's how this is going to look. I've got this right here, and then I have this right here, This is going to be angle X, and I'm drawing a right triangle. All right, so it says cosine X is negative 2/3. All right, cosine means adjacent over hypotenuse. So this side right here, this is the adjacent. This side is the hypotenuse. This one over here is the opposite. Cosine of X is negative 2/3. Well, remember, you can stick the negative either with the numerator or the denominator, but let's talk about which one it would make sense going with. If you're going to the left of the origin, those are negative numbers. So that tells me that the adjacent is going to be the -2, which then makes the hypotenuse the +3. So I've chosen to put the negative sign with the numerator because it would make sense that this adjacent side, because it's in quadrant 2, because it's to the left of the origin, that number should be negative. Then I need to use the Pythagorean theorem so that I can find out the opposite side. So I've got 4 plus x squared equals 9. If I subtract the 9 over, not the 9, the 4 over, I now have x squared equals 5. If I square root both sides, I get x equals plus or minus the square root of 5. But I can't put plus or minus. Here's where I need to think about that particular triangle, because here I'm going from here up. What happens to y values in quadrant 2? They're positive, right? Because they're all above the origin. So this is going to be a positive square root of 5. So the reason we have a negative over here is because we're going to the left of the origin. The reason we have a positive square root of 5 is because we're above the x-axis, and then that leaves us with that +3. So we now have a picture to use. So let's do cosine of 2x. I'm going to go with the first formula, which is the cosine squared x minus sine squared x. And this is where I need my picture. Now, well, actually the first part, I don't need the picture. We already know cosine of x is negative 2/3, and we're squaring it. Here's where I need the picture, because I need to find out what sine of x is. Remember, sine is opposite over hypotenuse. So opposite is the square root of 5. Hypotenuse is 3. That's sine of x, and we are squaring it. So I have cosine x squared minus sine x squared. So let's see what happens when we square it. Negative 2/3 squared is 4/9 minus the square root of 5 over 3 squared is 5/9. So we're going to end up with a negative 1/9 for cosine of 2x. There's one answer. All right, now let's go with sine of 2x, and there's only one formula for that. It's 2 times sine x times cosine x. So we're going to have 2 times, we already figured out that sine of x was the square root of 5 over 3, and they told us that cosine of x is negative 2 over 3, and we're going to multiply these. If you want, you can stick a 1 underneath the 2. Nothing can cross cancel, so I'm going to multiply straight across, and I'm going to get negative 4 on the square root of 5 for the numerator, and then I'm going to get a 9 for the denominator, and that is my answer for sine of 2x, because nothing reduces. All right, one more to go. So I'm going to need my formula for tangent of 2x, and that is 2 times tangent of x over 1 minus tangent squared x. So let's see how this looks. We're going to have 2 times. Now I need to find tangent of x, so I'm going back over to my picture. Remember, tangent means opposite over adjacent, so that is the square root of 5 over negative 2. So that is my entire numerator. Now in the denominator, I'm going to have 1 minus tangent x squared. All right, so remember, tangent of x was the square root of 5 over negative 2, and we're going to square that. So let's take a look at what happens. In the numerator, the 2's cancel, but I'm left with the square root of 5. I'm also left with a negative, so I have negative square root of 5. In the denominator, I have 1 minus. Now I need to square what's in the parentheses. The square root of 5 squared turns into 5, and negative 2 squared turns into 4. And if I'm going to subtract those, I'm going to need a common denominator. So let's go ahead and change that 1 into a 4/4. So now my numerator is negative square root of 5, and in the denominator, 4/4 minus 5/4 is negative 1/4. And then I'm going to multiply by the reciprocal. So I'm going to have negative square root of 5 times negative 4 over 1. And that's going to give me a value for tangent of 2x to be positive 4 on the square root of 5. And there we go. Now, one thing I do want to show you that I really like, which helps you out. If all I needed to find in this problem was tangent of 2x, then yes, let's use that formula. But here's the really cool thing about tangent. If you already have your values for cosine of 2x and sine of 2x, remember that tangent means sine over cosine. In this case, it would be sine of 2x over cosine of 2x. So I would take what we already found out, that sine of 2x is negative 4 on the square root of 5 over 9, and I would divide it by cosine of 2x, which is negative 1/9. I would turn that into multiplying by the reciprocal, and I would get the same answer that I got over here. So just throwing that out there, if you already have to find cosine of 2x and sine of 2x, then it's worth a shot of just doing sine over cosine, unless you just really want to do it using that formula, because they're both going to give you the same answer. All right, so example 2, it says cotangent of x is equal to 2/3, and sine of x is greater than 0. All right, so before I keep going, let's talk about this. Cotangent, where is cotangent positive? Well, all of them are positive in quadrant 1, and cotangent is also positive in quadrant 3. So right now, those are my choices, quadrant 1 or quadrant 3. Then we have sine of x being greater than 0. Well, that means positive. Everything's positive in quadrant 1, and sine is positive also in quadrant 2. So where do these things overlap? They both have quadrant 1 in common, so that's where we're going to draw our picture. We are going to be located in quadrant 1. So again, I'm going to draw triangle. X is the angle measure, and it says that cotangent is 2/3. So let's review cotangent. Tangent is opposite over adjacent. That means cotangent is adjacent over opposite. So adjacent is right here, and it's going to be a 2, and then opposite is going to be the 3. And now we need to come up with the hypotenuse. So we're just going to use the Pythagorean theorem. We have both of the legs, and we need to find the hypotenuse. 2 squared is 4, 3 squared is 9, and to get c by itself, we're going to square root, and we're going to get plus or minus the square root of 13, but we're not going to use plus or minus. Your hypotenuse every single time is going to be a positive number. So the only time that you're going to have negative numbers is if you have gone to the left on the x-axis, or if you've gone down on the y-axis. The hypotenuse will always be the positive version when you have taken the square root. All right, so we're going to start with sine of 2x. So I'm going to go back to my formula. And I think if you write the formula down every time you have to use it, it's going to help you learn it faster. So I'm going to do 2 times sine of x. So according to my picture, sine is going to be 3 over the square root of 13. And then times cosine of x, and according to my picture, that's going to be 2 over the square root of 13. And so now I'm going to multiply straight across. Again, if you want to put a 1 under the 2, you're welcome to. So in the numerator, 2 times 3 times 2 is 12. And in the denominator, 1 times the square root of 13 times another square root of 13 is 13. So sine of 2x is 12/13. All right, now let's do cosine of 2x. And I'm going to use a different formula just for the heck of it, really no good reason. So 1 minus 2 times sine squared x. So I have 1 minus 2 times, so going back to the picture, sine was 3 over the square root of 13. But we're going to be squaring that because that's sine x squared. So when we square that, that turns into 9 over 13. And when we multiply it times the 2, that gives us 18 over 13. And I'm going to go ahead and change the 1 so that it just has a common denominator. So it's going to be 13 over 13. And 13 thirteenths minus 18 thirteenths is negative 5 thirteenths. So there's our answer for cosine of 2x. And I'm going to take the shortcut here for tangent of 2x, which just means we're going to do this right here, sine of 2x divided by cosine of 2x. So sine of 2x is 12 thirteenths. We're going to divide it by cosine of 2x, which is negative 5 over 13. We're going to turn this into multiplying by the reciprocal. The 13s cancel out, and tangent of 2x is going to be equal to negative 12 fifths. So pretty easy. Just got to know those formulas. Okay, next example says to write cosine of 3x in terms of cosine. In other words, we only want cosines in our answer. So let's first of all talk about 3x. How can you get a 3x? Pretty easy. You add 2 x's to another x. So we're going to be using what we used the last couple of days. We're going to use the addition formula for cosine. That's Charleston County Schools stink. So we get cosine of 2x times cosine of 1x minus sine of 2x times sine of 1x. All right, now the key here is that we don't actually want to have sines in our answer at all. We just want to have cosines. And not only do we want to have cosines, but we want cosine of a 1x. We don't want a cosine of 2x. So I need to replace this, and I need to replace this, and I'm going to have to do something about that too. So let's start with this cosine of 2x. We've learned 3 formulas for that today, but only one of those formulas just has cosines, and it's the third one. It's the one that says 2 cosine squared x minus 1. So right now what I'm doing is replacing the cosine of 2x with what I know it's equal to, and then I'm keeping this guy, keeping it the same. Then I'm going to come over here to sine of 2x, and we did learn a formula for that. It was 2 times sine x times cosine x. So I'm replacing sine of 2x with all of that, and I still have the sine x. Haven't done anything with it yet because I'm not really sure yet what I can do with it. Okay, so over here, what do you think? I think we're probably going to have to distribute the cosine x. So I get 2 times cosine cubed x minus cosine x. All we did there was the distributive property, just distributed that cosine x to here. Back here, this isn't the distributive property. All of this is just multiplication. So if we multiply it together, you still have the 2. Sine x times sine x is sine squared x, and then we still have the cosine x. So all we did was multiply those together. That's where the sine squared x came from. All right, sine squared x. That's familiar because let's go back to what we had done previously with the Pythagorean identities. There we have a sine squared x. So what can we put in place of sine squared x? Well, if you got rid, or if you wanted sine squared x by itself, you would have to subtract the cosine squared x over to the other side. So I'm going to replace sine squared x with 1 minus cosine squared x. If I subtracted that over, that's what I would have. All right, so we have 2 cosine cubed x minus cosine x. Here we go. What are we going to do? Well, one thing we're going to have to distribute 2 different things. We're distributing a -2. We're also distributing a cosine x. What if I real quick just go ahead and move that cosine x with the -2? It might make it easier to see as you're distributing instead of having it split up in 2 different locations. So I'm going to keep everything up front the same. And let's distribute together. So -2 cosine x times 1 is -2 cosine x. And -2 cosine x times negative cosine squared x is going to turn that into +2 cosine cubed x. So we now have everything in terms of cosine x, but I think we can combine like terms because these 2 things are alike. So 2 cosine cubed x plus 2 cosine cubed x is 4 cosine cubed x. And then negative cosine x minus 2 cosine x is -3 cosine x. And so that's what that cosine of 3x that we started with would equal in terms of nothing but cosine x's. All right, let's talk about identities. We've been working on those, right? Let's start with the side that maybe is a little bit more challenging, which I'm thinking is going to be this left side over here. So first thing I probably need to do is rewrite sine of 3x. I'm going to rewrite the 3x as a 2x plus x. I'm going to keep my denominator the same. All right, well, in that numerator, I'm going to be able to use the addition formula that we worked on the past couple of days of sine. That's the South Carolina is a cool state. So I've got South Carolina is a cool state. So that's my numerator. And then all of that is over sine x cosine x. All right, so let's see. So what we're looking at on the right-hand side is cosine and secant. Remember, secant is the reciprocal of cosine. So basically, if I can get everything in terms of cosine, then I can probably get to where I'm headed. So that means we need to get rid of the things that are sine. So let's start by saying, okay, I need to get rid of that. And let's just start with that. What do we know about sine of 2x? Well, we learned today that it is 2 times sine x times cosine x. And then I still have the cosine x behind it, which doesn't totally get rid of my sines, but we'll keep going from there. And let's see. The other thing we notice is that these don't have 2 x's. They just have an x. So I need to probably do something with that. Well, that's the one that has 3 formulas. So which one should we try? Well, we're trying to get rid of the sines because we know we need to get to cosine and secant. So let's use the third one, which is the 2 cosine squared x minus 1. And then I still have that sine x behind it. So hopefully y'all followed me so far. All right, so let's start simplifying some things. So with this first one, the first part of the numerator, I have 2 sine x, cosine x, cosine x. I can rewrite cosine x as cosine squared x. And then for the second part, I'm definitely going to have to use the distributive property because there's that minus sign in there. So let's see what that looks like. So that would be 2 cosine squared x sine x minus sine x. So that is going to be my entire, oh, you know what? Actually, let's hold off on that. I have an idea. Sorry. I have an idea. Let's keep it written like that real quick. That's what I like about these problems is sometimes you don't get it right the first time and you just have to try something again. Okay, there's my numerator. And all of this is over the denominator of sine x cosine x. What if I just go ahead and split this up into two fractions? Put them both over sine x cosine x. And you might see where I'm headed with this. All right, let's look at the first fraction. What's going to happen? Well, sine x is going to cancel out from the numerator and the denominator. And then 1 cosine x gets to come out of the numerator. Did y'all see that? There was only 1 in the denominator. There were 2 in the numerator, so one of them is going to go away. So we're going to be left with 2 cosine x. All right, let's see what's going to happen with the second fraction. Sine x is going to cancel out. We're going to be left with 2 cosine squared x minus 1 over cosine x. What if we break that up into 2 fractions, both having that denominator of cosine x? Because right here, what's going to happen? There's a cosine x in the bottom. There's 2 in the top. So one of them in the top is going to go away. That's going to leave us with just a plain old 2 cosine x. Well, that 2 cosine x plus that 2 cosine x is going to give us a total of 4 cosine x. And then this turns into secant, which is what we had on the other side. All right, I liked that one. That one was fun. Almost done, y'all. 2 more examples. All right, so let's see. Example number 5 says, write the given expression as an algebraic expression in x. So in other words, we're definitely going to have x's in our answer. It's not necessarily going to be all numeric. So I'm going to start with this guy right here. It's been a while since we've seen him. Remember that that means, so first of all, inverse tangent of x. I'm going to set that equal to theta, because here's what that means. Tangent of what angle theta is equal to x. You remember that that's what that means? So tangent of some angle is equal to x. All right, well, let's talk about what tangent means. Tangent means opposite over adjacent. Well, let's make that a fraction then, so we can see the opposite and we can see the adjacent. So here, if I put theta, opposite is x, adjacent is 1, and we need to find the hypotenuse, don't we? So we have 1 squared plus x squared equals the hypotenuse squared. This just becomes 1 plus x squared. And then we have to square root, right? And remember, we said for the hypotenuse, it's only going to be the positive version. So our hypotenuse is going to be the square root of 1 plus x squared, or you might like to write the square root of x squared plus 1. If you like the variable in the front, that is totally fine. So right there, we have a picture. So here's what I'm going to do. I'm going to rewrite this thing. Sine of 2, and in place of inverse tangent of x, I'm going to replace it with the theta. And now we get to use the formula that we've learned today. The only thing that's different is instead of x, we're going to use theta. So this is going to be that formula that is 2 times sine theta times cosine theta. So instead of x's, we're just using theta. No big deal. That's where the picture is going to come in. So we have 2 times, let's go to the picture. What would sine of theta be? That would be opposite over hypotenuse. So we would have x over the square root of 1 plus x squared. Now we're going to multiply that times cosine of theta. Cosine is adjacent over hypotenuse, so we're going to have 1 over the square root of 1 plus x squared. All right, let's do some multiplication here. So if we multiply the numerators straight across, 2 times x times 1, that's 2x. In the denominator, what happens when we multiply those together? We get 1 plus x squared. So that would be our final answer to that problem. So again, if it says an algebraic expression in x, that means you're going to have x's in your answer. Now this next one says find the exact value of the given expression. We are not going to have x's. Let's see how this looks. Again, we're going to start with this. We're going to draw ourselves a picture. Remember, that means cosine of some angle that I'm calling theta is equal to 7 over 25. So here's my picture. Right triangle, angle theta. Cosine means adjacent over hypotenuse. So adjacent is 7, hypotenuse is 25. We're going to use the Pythagorean theorem. So we're going to have 7 squared plus, I'll call it b squared, equals 25 squared. So 7 squared turns into 49. And 25 squared turns into 625. Hopefully you knew that off the top of your head. And then we're going to subtract that 49 on over, and that's going to turn this number into 576, which is good news because that is a perfect square, which I'm really hoping everybody recognized as 24. So now we have a picture. So let's rewrite this. This is going to be sine of 2 theta. Again, we're going back to that formula. 2 times sine theta times cosine theta. So here we go. Let's use our picture. Sine theta is going to be 24 over 25. Cosine theta is 7 over 25, which we already knew that. So we're going to multiply straight across. So 2 times 24 is 48, and 48 times 7, I believe, is 336. And then in the denominator, 25 times 25, that's easy, that's 625, and that does not reduce, and that is the final answer. All right, so today was all about double angle formulas, more formulas. I know this chapter is all about formulas. Guess what? Tomorrow is more formulas. We're going to do half angle formulas. But go ahead and work on the homework for tonight. Let me know if you have questions. Shoot me an email, and I will see you in the next video.